Okay, I'd like you to pause the video, try this problem, and then start the video up again. Alright, this is the human memory model, and it approximates the percentage of information the average person can recall after a certain period of months have passed by. And this is the equation right here. F of t equals 75 minus 6 times the natural log of t plus 1. You see, here is a restricted domain. This model is good for a year, so it's only good for 12 months. This data was collected, and using certain statistical analysis, they came up with this formula. So the first question says, what percentage was retained 6 months after being presented the information? And so this is a straightforward. T is time, f of t is a percentage, and so we want to know f of 6. We'll just substitute 6 in wherever we see a t, so 6 times the natural log of 6 plus 1, or in your calculator, f of 6 would equal 75 minus 6 times the natural log of 7. So let's evaluate this. We can have 75 minus 6 times the natural log of 7, right, which is 63.3. Let's round this to the nearest whole number. So f of 6 is approximately 63%. So approximately 63% of the information is retained after 6 months. All right, now let's look at part B. After how long did the average person retain only half of the presented information? And then once you get your answer, the question is this answer valid? And so if you're retaining half of the information presented, that's going to be 50%. And so f of t is a percentage, so we're replacing f of t with 50 is equal to 75 minus 6 times the natural log of t plus 1. We need to solve for t plus 1. We're going to subtract 75 from each side. We'll get negative 25 equals negative 6 . Negative 6 times the natural log of t plus 1. Remember, our goal is to isolate that natural log and get a constant on the other side. When I divide by 6, I get 25 over 6 equals the natural log of t plus 1. I can now change this to exponential form. So the base is e. E to the 25 over 6 equals t plus 1. Subtract 1 from each side. That gives you t is equal to e to the 25 over 6 minus 1. Let's evaluate that in our calculator. So we're going to have second e to the x, or you can use the caret key like we discussed before. 25 divided by 6, close the parentheses. If you have the newer version, hit that arrow to get you out of the exponent and then subtract 1. And so t is approximately equal to 64. But that means t is in months, so that means 64 months. And so the question is this answer valid? And the answer is no, it's not valid. And it's not valid because this particular model is only good for a year, within a year of when you heard the information, and so this is not valid. Now let's try the Richter scale problem. And the Richter scale measures the magnitude of the seismic waves of an earthquake. So an earthquake measuring 6 on the Richter scale has seismic waves 10 times greater than the amplitude of those measuring a 5. So for an increase of 1, or every increase of 1, you actually have a 10 times greater in magnitude, or a 10 times increase in magnitude. So the formula for the value of a Richter scale is r of x equals the log of x over I sub 0. X is the intensity of this new earthquake. I sub 0 is the intensity of what they call a standard 0 level earthquake, which would be considered 1. And so this first question, if an earthquake is measured as having an intensity of 100 times that of a standard earthquake, what is its value on the Richter scale? And so x is the intensity. So I want to find out r of x. So r of x would equal the log of x, which is 100, over standard intensity, which would be 100. So 100 times greater would be 100 to 1, which is really just equal to the log of 100. So that what to the 10 to what power gives me 100, which would be 2. So it makes sense that a Richter scale value of 2 means that your earthquake, that earthquake is 100 times stronger than that of just a 0 scale or a 0 level earthquake. Now let's look at part B. We've got the 2004 Indian Ocean earthquake is estimated to have been about 9.15 on the Richter scale. This is the second largest ever recorded and really is absolutely huge. It says find the intensity of the earthquake using I sub 0 equal to 1. So we'll first write down the formula again. We've got r of x equals the log of x, which is the intensity, over that of a standard 0 level earthquake. We know that 9.15 is the value on the Richter scale. That is my r of x. We have the log of x, which is our intensity. That's what we're looking for. We let I sub 0 equal 1. So we have 9.15 is equal to the log of x. We can now rewrite this in exponential form, which means that x is equal to 10 to the 9.15. So let's evaluate this on the calculator. We've got 10 raised to the 9.15. Alright, we get 1,412,537,545, which is absolutely massive. Okay, that means that this earthquake is, over 1 billion times stronger than a low-level minimal earthquake.